Welcome. In today's tutorial we will be designing and implementing Bimodal biometric-based surveillance system. The project will be able to detect motion gesture at a model door, then ask the user to check for fingerprint verification. Once this is successful, ask the user to verify their face recognition, and after that it will automatically open the door for the user to pass through. Without further ado, let us get into details on how this was built. While you are at it, you can take a moment to like and subscribe to our YouTube channel. It will encourage us to make future videos like this. Let us start with the schematic diagram and its explanation. Here is the schematic diagram used for this project design. It is built around the Raspberry Pi 4B and the Arduino Nano development board. Detailed and well-described diagram of all of these is found on the blog page in the description below. Please see the link in the description below for further explanation. Now let us program the Raspberry Pi 4B for the face recognition program. The face recognition Python code can be found in the link in the description below. A big part of this Python code is gotten from Tines hardware. Thanks to them, we were able to program the face recognition part very well. It took around 4.5 hours to code the whole Python code, also to install the dependencies and the libraries needed to make it work. We had to use the OpenCV machine learning library. Some modules too were needed and they were equally installed. You may find this part a little bit frustrating. However, if you run into any problem, kindly let me know in the comment below. There are some tricks though needed for some of the libraries and dependencies. You may have to use some old libraries for this to work as expected. You can also check Stack Overflow for some tips when you come across such challenges too. We had to install the fingerprint library for Adafruit. This module worked very well for us. To install this we used pip3 and also parsed it after installation. A quick run test on the Raspberry Pi command prompt, after training the datasets, will show something like this. The face recognition should be able to detect and recognize faces when they appear across the Raspberry Pi CSI camera. Now let us proceed to encasing and coupling the project design. To encase the Raspberry Pi 4B and the Arduino board, we had to use a 6x6 plastic box as shown here. Some openings were made at it. These will allow air vents and entry for connections and power points. For us, the Raspberry Pi 4B will take care of the face recognition and fingerprint biometric verification, whereas the Arduino Nano board will communicate with the Raspberry through serial communication to display to the user what the project is doing and what it requires from the user. The project was designed to use a 20x4 LCD module. This will be interfaced to the project design and mounted on the top of the casing where it can show the user what to do. As a backup we used some series-connected 3.7 volts LiPo batteries to power the project design. Since the project itself was meant to open a 12 volts DC solenoid lock when the face and fingerprint verification was successfully passed, these batteries could be recharged by plugging them to a 12 volts DC charger. Once we are done, we tidied up the inside, taking care of the wiring by neatly securing them with small cable ties to make the inside of the design presentable. The cable ties would be later trimmed to ensure neatness in the enclosure. Next on the list is the connection of the CSI camera. It should be placed where it will be very visible. Hence we placed at the top covering of the plastic box, and used some glue stick to hold it in place. Now, let us model the door. We needed a door that would be locked when there was no verification, and we also needed the door to open after successful biometric verification. We modeled such door using this wooden framework. And on the door, we attached the solenoid lock on this door model. We will connect it to the design and energize it or de-energize it using a transistor common emitter follower. Now let us do some laboratory test for the design itself. The project design has been programmed to work thus: sense when there is motion or gesture at the door, ask for the fingerprint verification, and if the fingerprint was found in the database, it will proceed to face recognition, and if the face of the user was recognized, it will open the door for the user and the user can pass through.
Yeah, go ahead. Oh yeah, go ahead. Okay.
And that is it for us on this video tutorial. Please leave a comment below if you have any question. See you on the next video and thank you for watching.